Record, okay?
Yeah.
Just make sure you hit accept so that it,
Oh yeah, got it. Okay, is that shared up now on the Zoom window as well?
putting up mine. Did you click the okay, got it on the screen share?
Yeah, I clicked okay, got it. Actually screen share is paused. Oh. Is that's still loading on?
I asked in the chat because it's not loaded on mine, but that doesn't mean it's loaded, not loaded on each people.
Oh, okay, let's try that again.
Yeah. Still doing this as you started, but it's paused. Ah, yeah, is there a way to unpause it there?
Ah, I see, is it because I'm on a
I think because that was on the speaker notes screen, so maybe that's why it's doing that, but I don't know how.
yeah. Should I do a mirror displays or something? I could.
Do you need the speaker notes?
No, not
Oh,
all.
okay.
No,
Then
the
maybe, yeah, maybe that would work. I've never seen it do the pause thing before. So yeah, if you just open it in full screen
Yep.
and then just share only that, maybe that will work. Is it the third one that does the full screen? What does that do? Nope. There, and now just share that one.
Oh, that's
I was doing the opposite up here.
I could select mirror displays on the on
Maybe
the
just the
settings.
button. Maybe that one is the right button.
This one?
Yeah, try that. And it's doing it still. Okay.
So this
Yeah, no
hasn't
worries.
happened before. I shall displays. Usually there's an option to
Yeah.
displays also.
You have to select the other one. Maybe if you go to view and then just full screen or something, is there slideshow? Maybe slideshow? There's a number. It's still showing the speaker view. We don't want the speaker view, we just want the slideshow. End it. Yeah, I don't know. I don't know why it was doing the pause thing.
Yeah, it's on.
Okay.
There we go. Oops, you can look at this, that's fine.
Are you sure?
Yeah,
It's not gonna be it's gonna
What happened?
It's black.
Oh, it's not again.
Use slideshow.
I feel like usually you can, there's a way in PowerPoint to just not do the presenter view.
yeah, they usually
But it's not working.
Yeah. That's working.
Okay.
Thank you.
Now it's gone again.
I think maybe if you just do, yeah.
Yeah, maybe just do it and just show the whole thing, if that's okay with you.
If
You could also export
Just-
the PDF and open it that way if you wanted.
yes, I can. Yeah, I was because I've got
Oh, do you have something?
transitions.
Instead of that, if you just do play from current slide, present from current slide, one of those. Yeah.
And this doesn't show on the Zoom. So
Nothing's showing on the Zoom, it's just black.
let me just take the HDMI out and put it.
Oh, wait,
Is it the HDMI constant
It
problem?
just worked.
Yeah.
It just worked. It just worked. It just worked.
it's working now.
Yeah,
Is it working?
yeah.
Yep.
Yeah.
still
Amazing. Okay,
That's
yeah,
right.
HDMI itself. Yeah.
same-
Yeah. Okay, yeah. Nice. Okay, so as long as you don't mind the tiny screen of there, you can see on Zoom. Yeah. So that thanks for again. So just a small update, because the reason I had to reschedule last time was because our cat was very severely ill and had gone into hospital, but he's doing okay and he's in getting treatment at the moment. So yeah. So just a little bit of background on myself. As Tim said, I'm a postdoc at Northeastern London at their new Network Science Institute. There should be some events later on in the year for people to come and see some talks by Wood. So I'm really looking forward to that. But before that, my background's in mathematics, where I did my undergraduate. And then moved into network science in a computer science department for my PhD at Queen Mary. And my introduction to that was from a perspective of modelling networks that grow in time. So I was developing some software for modelling network growth and inferring different network models. During the end of the PhD and when I was starting on my postdoc, I got involved in a project called Raftery, which I'll tell you a little bit more about in the talk, but it's all about analysing temporal networks and time varying networks as a whole, not just modelling. And this was at Queen Mary and funded by the Alan Turing Institute. And Raftery has been recently spun out into a company called Pometry, which are adding some things on top of that and doing some consultancy. So in this session, we're going to firstly just introduce a little bit about the Raftery project as a backdrop of why temporal networks are perhaps interesting. And then talk about my project that I was doing in the postdoc and still a bit now on how we were using temporal motifs in dark web marketplaces. And if there's a significant amount of time left, I might show you a quick demo of how Raftery works and things, but that's not super important because there are some notebooks online for that. And if you have any questions, please feel free. I can see just about the Zoom chat, so if you want to shout out, raise a hand. I've prepared a talk for about 30-40 minutes, so should be more than enough time to just jump in with questions. So a little bit of a backdrop and my motivating why I want to look in temporal networks and developing tools for them. It's the backdrop of why they can be a bit of a nightmare to code and work with. So I think possibly before Raftery and before there's if you wanted to do something with temporal networks, you'd have a data set of maybe, let's say, interactions. And if you want to do some sort of rolling window analysis of looking at that as a network, say want to get the weekly page rank scores of a particular network going from the start and the end, I think something like this would be maybe a fair definition of how you might do that with like pandas and network X. So reading the interactions into some sort of data frame, and then have some sort of windows and time ranges that you're interested in, and gradually filter that data set down into these different windows and run the analysis on this. but this can be quite hacky. So there's with anything like this, I always struggle sometimes with pandas errors getting these to work. But then if you want to add anything else on top of that, like change or add new window sizes, or instead look at the aggregate graph rather than a particular or some extra filter on top, it can get a little bit hard to express what you want from it. And another problem with that is being able to get it to scale to larger network sizes, because without sort of digging too deep into the code itself, using those sort of methods you might make yourself, you end up maybe making several passes of the data, one for each time point, and building up and then discarding many individual like graph objects, which is not something that's ideal for either large networks or long time periods if you're having to make and destroy all those things. And another thing is when we talk about temporal networks, and there's lots of different ways you might see a temporal network being. Some people would look at temporal networks as a snapshot of different static networks. Sometimes you think of it as a growing network where the links are only arriving. There are things about if you have nodes and edges with duration, something like a contact network or transport network. And if you're rolling your own solution for these, it can get quite faffy and have to maybe rewrite a whole different piece of code for a new data set rather than like just modifying it slightly. And that's not to bash any of the existing great tools out there, just that they're not designed with temporal networks in mind. And so the Raftery project was something that the college at Queen Mary and UCL developed and has now been spun out to Pometry. And this was a platform designed especially for like large temporal networks. So you can attach data from anywhere, whether it's like a CSV file or if you have a stream of data somewhere else. You can specify how you want to convert that into updates to the network, like adding a node, removing a node, adding property to different time points. And this is then stored in Raftery as a full log of all the events that happened, which can then be sort of more efficiently filtered down to seeing different views of what your graph looked at different times, with a user endpoint for looking at those different points in history. And it has a number of different algorithms out of the box, like some of the more traditional static graph algorithms that you might expect, like centrality measures, pathing, but then some more temporal focused metrics like temporal motifs, and hopefully soon some temporal community detection stuff as well. And so just to give a flavour for some of the things that Raftery has been used for, and I think all these have a piece on the Raftery blog. There was some work with a legal company who had 400 years of citation network data, where you had legal judgments that used another one as precedent. So it formed this like long-term citation or precedence graph, and it was across the world as well. So countries citing other countries' rulings. And this was a project looking at how the change of influence has happened over time, where there's sometimes where the UK has become a legal authority, and other times when that's sort of dwindled, and these sort of cross-border sightings. Some other recent work has been looking at NFTs and detecting NFT cycling schemes where people are effectively the same person passing NFTs amongst themselves to try and up the perceived price of the asset for some parcel to buy in, thinking like, wow, this is yeah, going. And then another piece some of the people at Poetry have been doing is looking at data from Companies House, where people register the company and percentage shares and things, and that has full temporal history of who's owned what portion of the company at what time. And they did some work looking into the COVID PPE schemes that have been awarded, where people had been awarded maybe a multi-million contract to make what ended up being sort of substandard PPE, and then that company mysteriously transferred ownership at some later point. So it's quite a wide range of applications involved in. On the Raftery website, you can maybe take a look at these if you're interested. But the main focus of what I'd like to talk about today is some research I did during my postdoc at Queen Mary, using temporal motifs implemented in Raftery to study dark web marketplaces, and some of the findings we've had on that. So just to give a bit of context into what a dark web marketplace is, and what why we might want to study it. We were looking at this particular case called Alphabay, and a dark web marketplace like Alphabay is somewhere where it operates on the dark web, hence the name, and it tends to where people buy and sell illicit goods, and there's been cases of drugs, people selling stolen data as a way of almost like a fraud package to do it. And payments on there are made in Bitcoin, which as I guess then data scientists, because those payments are those transactions are all public, we can study those. And in the case of the Alphabay marketplace, this was shut down in an operation called Operation Bayonet in 2017 by the FBI. But it's an interesting ecosystem, because even though that was shut down, others very quickly pop up afterwards. So there was a paper that was studying this a couple of years ago, where they were looking at all these different dark web marketplaces and when they were formed and shut down. And you see, so the bars are when they were formed, and then when they either shut down voluntarily or they were raided or something. And there's this gradual shift of there's always one that pops up to take its place, because there must be some sort of demand in there. So why we might want to look at temporal motifs in Alphabay and in the ecosystem as a whole. Firstly, that might want to look at how dark web marketplaces like that work. So if you are accessing Alphabay and buying some goods, what happens is Alphabay acts as an escrow service. So if you see something you want to buy, you make a transaction to Alphabay as an escrow, and then the seller sends you the goods, like this parcel here, and if you, provided you have received the goods, you can give that the Alphabay the okay to release the money. So it has this sort of conveyance type motif of receiving and then sending out. Some other interesting things you have in the, I guess, the wider Bitcoin ecosystem is exchanges, where people pay real world money and then as an on-ramp to get Bitcoins, and the same with off-ramp of if you've made some money and you want to cash out for fiat currency, you can do that through exchanges. There are also peer-to-peer transactions. So on some place like Alphabay, what can be the case is that if you've been buying from a particular vendor for some time, Alphabet takes a small transaction fee. So if you decide you trust that person, then maybe you start trading with them directly and cutting Alphabet out. But then something that happens as well is a mix of transactions. So say if you had that same transaction of teal to orange, you can obfuscate that by these mixed services where it gets many people who are wanting to make a more discrete transaction where the coins are essentially mixed and so if you were trying to follow the money through where it's gone to, it is not sure who the intended source and recipient are. So these are all sort of interesting patterns that we might expect to see in looking at data like this. So the next question remains is I've sort of casually thrown away around the word temporal motif without specifying what it means. So we use this definition of a delta temporal motif, which is there was the original paper in 2017 on this who came up with this sort of general way of defining them. And a motif is a small subgraph that might look something like this with, in this example, 3 nodes and 3 directed edges with an order on them. So the edges happen in the order 1, 2, 3. And along with this is a parameter delta, which is a time window by which the motif has to complete. So it's the difference between the difference between the last transaction and the first transaction has to be smaller than delta. So it might be like minutes, hours, days, depending on what sort of patterns you're interested in finding. So as an example, if you see something like this in the graph, this would be an instance of the motif you're interested in because the edges are all in the right order and the time difference is small enough. This wouldn't be because the first and last edge, 5 and 21, have too large a difference. And then I think in this instance, the edges are happening in the wrong order, so it wouldn't be an instance of that motif either. So to kind of bound the motifs that we're looking for, we use the paper from the motifs from that original paper that focus on up to 3 edges and up to 3 node motifs. Sorry, that might be a bit tiny, but so there are 36 possible motifs when you account for all the different orders and combinations of edges on these. And the delta we use is 1 hour for most of the results on here. And if there's some time at the end, can maybe show some justification on why that delta is used. So to break up the grid into the classes that are more meaningful, in this bottom left corner, there are motifs that happen just on 2 nodes, which are back and forth between 2 individuals. There are motifs which are all outgoing from 1 node, sort of possibly representing like a fanning out of money. There's the opposite of that where money's all incoming, and then in these slightly greyed sections here are the triangle, the motifs which actually form a triangle. Everything else is sort of a mixture of incoming and outgoing from 1 central node. And in the experiment, we were using a data set from the company Chainalysis, who they had of users who had transacted with Alphabet at some point, as well as their transactions. So essentially going out 2 hops from the Alphabet market. And this data set was prepared so that if there were different wallets who were all believed to be the same person, these had been merged together beforehand. And altogether, this is about 11 million nodes or users and 33 million transactions, and was all implemented in Raftery. And we're going to look at the local motifs, so the motifs that each node participates in, as well as global ones. So first off, if we just look at all the motifs that happen in alphabet, a quick sort of how to read this plot is that it's essentially the same grid as was on the previous picture, but a quick way of how to read it is the row represents the first two edges of the motif, and then the column represents the third edge that would happen in the motif. So these dark patches here, the three there, these represent motifs which are all outgoing, and they're in the trillions, in which is obviously it seems quite large. Then another motif which was still an order of magnitude down from that, but was fairly common, was pairwise, one direction, all outgoing motifs between two users. And then possibly the next one down on the magnitude was the motifs which were all incoming to one node. And we found actually that at least for this delta is 1 hour, the triangles were fairly low, like in some of them in the hundreds of thousands. So maybe a window of that size is just not big enough to sort of capture some of those triangle interactions. Yeah.
The window's rolling, right? So one edge can be part of multiple trees.
Yes, yeah, that's right. So yeah, so one transaction might be part of many different motifs, and there is a little bit of a combinatorial element into it. If say one entity has thousands of transactions within an hour, that's going to make up that many motifs just because of the ones that can be made out from that, and might be able to talk about that at the end. With we had a little look at how do you maybe account for that to see how many of those are just sort of by chance.
So is alpha B one of the nodes?
Yeah, alpha bay is one of the nodes itself. So all the data set was like starting at alpha bay and going out 2 hops. But yeah, so our next step was to look at I think most of the works on motifs are focused on the graph-wide counts, but then we looked at the each individual node, how many motifs of each type they participate in. And we group those into different categories, so there's not 36 or 40 different lines on the plot, and looked at how those are spread. And this seems to be very heavy-tailed of, and see that some of those numbers of trillions we had in the first plot is mostly coming from just 1 or 2 that super nodes in the data set. So those are our different groups, and we'll use those in the later on in as ways of grouping the motifs to get into sort of similar structures. Yeah.
So related to Rohit's question, so when a node has a motif count that's in the trillions, that doesn't mean that they have a trillion transactions.
Yes.
Because things are being counted multiple times because you're shifting the window.
Yeah, that's right. Yeah. So so if you had 1,000 transactions all within an hour, then it's going to be something along the lines of like 1,000 choose 3, like not quite. It's but yeah, it ends up being a bit
Does the transactions per node distribution look quite, I imagine it's heavy-tailed as well.
Yeah, that's a good question. I think it was fairly heavy-tailed. But surprisingly, I'll talk about this in a little bit, but whilst it was something that was correlated with degree, as you sort of might expect, but it was quite loose in that there was nodes which might have 1,000 transactions, but the motifs they're involved in might be between like 10 and billions. So it really depends on sort of how those transactions are distributed in time for that node. Yeah. So if we like take a look at this, so what's going on in this heavy tail, like who are some of the big important nodes in motifs? We had a look at just two of the nodes. I think the left one is the top node in number of motifs, and the second is somewhere in the top 5. And we see that this node here with the counts in the trillions is probably responsible for like most of these all outgoing motifs. And we thought actually when I was making this presentation that it might be a mixed service or perhaps a crypto on-ramp, but then later we were trying to sort of find out who it was, and I think some of the wallets in this cluster were actually associated with some 10x your Bitcoin scams. So we're just not sure exactly who it was, but it seems perhaps there could be more to investigate there. It's like, why is this node? And also, in particular, this isn't the Alphabet node. So whilst Alphabet had the most incoming and outgoing transactions by far, it wasn't. It didn't come up in the as one of these nodes in the top 5. This node, on the other hand, represents all incoming. So has most all incoming motifs. We haven't managed to identify who that one is, but we wonder whether it could be, say, a particular big vendor on Alphabet, or perhaps a service like an exchange. And then interestingly, when we knew the idea of the Alphabet node, and that was one that didn't even come up in the top 10 for number of motifs, although it had the highest degree by far. So it seems sort of interesting that this method can pick out maybe nodes that might not always be like way out the head of things. And I quite like that in Alphabet you have some of these outgoing motifs, the darkest ones, but then the sort of second darkest ones represented motifs which are involving some receiving funds and then sending out, which is sort of consistent with what Alphabet is as an escrow service. Then, oh yeah.
So do you think the reason that this conveyance one isn't the top for Alphabet is the time window? Because it actually takes more than an hour for many of the conveyances to happen.
I think you're right on that point, because it's most of these things might be by some sort of postal order, so it might be on the order of a few days. There is actually something interesting there that happens with this when we looked at different time windows, which I'll possibly add on at the end with relating to this like this timing out of people releasing the money from Alphabet.
Mm-hmm.
So our last point of inquiry on this was looking at if instead we look at motifs over time as well, and not so what we did here was we looked at group the data into months, and still using the 1 hour window, looked at the number of motifs of different types in one month. And then we plot that against the red dotted line is the number of transactions in the month. And so just pointing out some points of reference, it was in around 2014 when Alphabet was formed, and then summer 2017 when it was shut down. The first thing is that the very first motif burst, so not the huge one, but it's hard to see on here, but there's a really tiny one there. That was actually when the Agora marketplace, so which was another dark web marketplace, has shut down. So even though the transactions had been sort of steadily on the increase in self-pays and donation, it was possibly the Agora market shutting down that might have coincided with a bit of an increase in some of the motifs. But this really huge motif spike is in early 2016, and I think most of that is associated with that Supernode wallet. And we're still trying to pin this down, but don't know that there was aware of some like compromising event in February 2016 involving phishing attacks on Alphabet, but I'm not certain whether it is that. But what's quite interesting to me is that this spike dies down like long before the number of transactions associated with Alphabet dies down, and long before Alphabet is shut down as well in 2017. Then what we did was taking that plot that was looking at the total number of different motifs, we looked at that as a composition of different motifs, so which motifs were most common as a proportion. And what we see is that right up to sort of early 2016, most of the motifs are dominated by this green and blue, which are all motifs that are happening on just two nodes. So like pairwise transactions, and then possibly at the time this supernode comes about, this switches to being all these big star, all outgoing motifs, which would possibly be consistent with okay, before Alphabet, people couldn't transact through Alphabet and were maybe just having peer-to-peer transactions, and then Alphabet came about. But then when Alphabet is shut down in 2017, instead of sort of returning to these pairwise motifs, it's still apart from very briefly dominated by sort of the star type motifs. So perhaps people moved to a different market or still using some of the services they're involved in those motifs. Then looking at possibly the future is that when we were doing these local motif counts, this gives us for each of the nodes like a vector of the counts of different motif types that they were involved in, and we were interested in if you look at the nodes motif counts, could this be an interesting feature to cluster on? Like, do you get people with similar proportions of motifs, and might there be something to helpful to find different roles within the system? So this is like a very early stage plot using some k-means clustering, and I think we use the TSNE method to embed those based on their motif participation, and it seems like there are at least some small groups which tend to cluster quite well. Unfortunately for this data set, apart from a tiny handful of nodes, we don't have much labeled data on whether nodes are buyers, sellers, or a particular service. But I think it would be interesting if we did have a data set at some point which has some more labels on it as to whether this can be used as a method. Yeah.
So do you distinguish what role the node plays in the motif?
Okay, yeah, that's a good question. So we made this decision that for so for the motifs that are the star motifs, we only count it for that node if it's the center of that if it's the source of the node, which, and then whereas for triangles, every node counts that triangle, and then for the two node motifs, whereas there are only 4 of them in the if you're counting them on the graph wide count. When you look at the local count, we would split it into the directions that they form. So it would, each node would have 8 possible 2-node motifs it's involved in, because the motif which was like one way out could also be in for another node. So when on the local nodes, we sort of distinguish between those different directions as well. Yeah, it's a good question. So just to wrap up this piece of work and things, we quite enjoyed looking at temporal motifs and found that it gives some like a bit more information than looking at degree and some more basic graph metrics over time. But the time requirement for the complexity time requirement for running it ended up being not the bottleneck of the algorithm for us was running the finding the triangles in the network. So that's where so it's not got much more requirement than a triangle count per se. And then yeah, we found some important nodes which are not necessarily flagged up by or at least not in the very top 5-10 looking using other centrality measures like degree. And this could be quite interested in the crypto setting with the different services and roles in the network. And then also it seems like we can possibly see some events looking at motifs as well. So yeah, thank you very much for listening. Yeah, here's some people involved in both the Raspberry project and the motifs work, and would love to answer any questions. Yeah.
Great, thank you, Naomi. I think there's a question in the chat.
Lovely. I think I've lost my cursor. Could you read out the question?
And also, I think people can unmute themselves. So if
Oh yeah, perfect. Yeah.
if Shahar, because you have the audio on your laptop.
Yeah, I'll put it on full blast.
Yeah.
So we can.
Shahar, if you're there and you want to ask your question out loud, you can.
Hi, Naomi. Thank you for your talk. It was very interesting. I'm Shachar. I'm a postdoc here at MIT. And I was wondering, how does this temporal motifs clustering is better or different than clustering based on non-temporal motifs?
That's a good question. We haven't actually looked at the static temporal motifs. So I guess the equivalent would be maybe if you're looking at sort of triangles in degree of certain time period. The clustering itself was is quite sort of a laid work here, but I think that would be a good thing to compare. See what we can gain more by using temporal motifs and not the sort of directed static ones. But yeah, thanks.
Okay, thank you.
Don't see anyone else on here yet, but I have one. So thanks for the talk, first of all. There's like an interesting implied link prediction problem in this kind of study of marketplaces, and I was wondering if you, because like assuming basically you have missing links in terms of like someone is posting something in the mail like to someone, you know that there's links missing, that you kind of infer if I gave money to the marketplace and then the marketplace gave money to this other person, you infer that you could infer that there's another link. So I wonder if you like thought about how to like integrate that information, and relatedly, do you see a lot of transactions where it's clear even within just the hour that link didn't happen and that the money went back to the original person because they backed out of the transaction or something?
That's a really good question. I think it would be it could be difficult because you have because transactions are grouped by block. There's maybe many transactions that happen in one thing, but that would be very interesting. We one thing on the some like quirks of the escrow service which we found on was we were looking at the time windows and how you as you increase the time window, how many new motifs of each type do you see? This, it was quite peculiar compared to some other data sets for like social ones, because normally you'd expect some sort of daily periodicity in that, but we didn't seem to see that here. But instead we see after the initial burst that dies down, the next big burst is a week after the first edge happens. But why on earth is that? And it turns out that it's we looked at the alphabet terms and conditions, and if you haven't approved that you've received the goods, then alphabet or asks for an extension and raises a problem. Alphabet just releases the money to the seller, so you've not just run away with the evidence. And so I think this when we see this on spike at a week, we think this could be the automated release of funds on there. But that's I've never thought about the link prediction problem from there. I think it'd be interesting. Yeah.
Are there any use of amount or something in these things?
Yes, yeah, we have a transaction amount in Bitcoin and things. So
So I read some notes that are big spenders or big receivers.
yes.
Or is it mostly just people, like do some nodes end up net positive, some end up net negative?
Yeah, there's and I should put the plot in there. We had some plot looking at the distribution of the degree, number of transactions versus the number of motifs, and then also the wallet balance as well in there. And so you do get some extreme the balances of nodes. When we were trying to work out who this strange node was that was creating loads of motifs, like it had a very small number of sources, but then a huge, so a low in degree, but then a very, very large like fan out of out degree, and then slightly negative balance. Although there was still many incoming transactions among those sources, and so and at first we thought that might mean it's a crypto on ramp or something, but given it could be associated with some sort of scam, maybe this large out degree is like trying to launder its incoming or something. So there's some interesting when you're combining it with looking at the in degree and transaction ones.
Related to that, I was wondering if now that you have some suspicion that this is a fraudulent account, is there a way to do the analysis without it, or would it? Like, is it so well connected that it would kind of break a lot of the statistics?
Well, we did do some plots without that entity in there, and it resulted in that original plot where it was like all really 3 dark spots and everything else much lower orders of magnitude. When we removed that top person or top few nodes in there, the motifs were a bit more spread out, like still concentrated on some patterns, but more
Right. Don't see any more questions online, so maybe we can thank Naomi again.
Thank you so much for joining.
Nice job, Naomi.
Thanks, Phil.
Yes, bye.
Thanks, everyone, and we'll be back next term. So keep an eye on the email list. Bye-bye.
Thanks.
Yeah.